expressions. All right, so 5 pi over 12. Now, if you divide, now it says, what does it say? It says use half number or angle identity. Use half number or angle, use the half number, half angle, whatever you want to call it. So that means that I probably need to figure out what this is. And 5 pi over 12 is half of 5 pi over 6. How do I know that? Because if you was to multiply this by 2, if you was to multiply it by 2, you would get 5 pi or 10 pi over 12, which is 5 pi over 6. So with that, just that little bit of math right there, 5 pi over 12 is half of 5 pi over 6. Therefore, A is equal to 5 pi over 6, and A over 2 is equal to 5 pi over 12. Because you got to think like that because you're using a half angle identity. And this is not focused right. There we go. So on this one, on this problem right here, you would multiply that pi over 2, pi over 12, you multiply that by 2. And I'm going to just start you off on it. I'm going to switch right here. So pi over 12, you're going to multiply that by 2, and that's going to give you 2 pi over 12, which is pi over 6. So now you can say pi over 12 is half of pi over 6. Therefore, A is equal to pi over 6, and A over 2 is equal to pi over 12. And this right here kind of helps you get started with the half angle or half number identity. I printed out my cheat sheet a while ago and I put it somewhere and I can't find it, so I'm just going to write down and hopefully I can remember what I can remember. All right, so this is the problem that you're actually doing, and you're going to be working with these two angles right here, pi over 6 and pi over 12. So let's go back to the one we were doing. And we were doing 5 pi over 6. 5 pi over 12 is half of 5 pi over 6. So sine of pi over 2, or sine of A over 2, is equal to positive or negative square root of 1 minus cosine of A over 2. And we know it's going to be in the first quadrant. So 5 pi over 12 is in the first quadrant. Both of these are in the first quadrant. So with that being said, we're going to use the positive. So sine of 5 pi over 12 is equal to the square root of 1 minus cosine of 5 pi over 6 over 2. And now you're just going to finish it using what you know. You know that 5 pi over 6 multiplied by 180 over pi, that goes out. 6 will go into 80, 30, right? It's 75 degrees, isn't it? I might be wrong. What's 5 pi over 6? Somebody do 5 pi over 6 for me. Somebody.
It's 150 degrees.
Yeah, I got 150 degrees.
Well, that's in quadrant 2. It should be in quadrant 1. 5 pi over 12. I'm sorry. 5 pi over 12 is 75 degrees, isn't it? Somebody do that for me.
Yes, sir. That one should be.
Okay. It's in quadrant 1. 5 pi over 12 is in quadrant 1. So you're going to use the positive, okay, because you're doing 5 pi over 12. So it's going to be a positive. All right. Anyway, 5 pi over 6, you do the math, it comes out to be 1 minus a negative square root of 3 over 2. I'm going to go to the next page. So sine of 5 pi over 12 is equal to the square root of 1 minus cosine of 5 pi over 6 over 2. And that's going to give us 1 minus a negative square root 3 over 2, I believe. Yeah. Negative square root 3 over 2 over 2. I swear I think we did this one at the end of class the other day. I remember doing this one. And that's going to be equal to the square root of 1 plus the square root of 3 over 2 over 2. And we need to multiply. I know I did this one. I know I did this one. And we're going to multiply by 4 because that's going to give us, 2 here and 2 here. And that's going to give us the square root of 2 plus the square root of 3 over 4. And that's going to give us 2 square root of 2 plus the square root of 3 over 2. And that's equal to the sine of 5 pi over 12. Somebody tell me, look in their notes and see if I did this problem. I believe I did this problem.
I don't see it in the notes, but we might have done it.
I might have done it later. I can't remember. But it sure does seem familiar. Okay, so that's that one. So if you did this one, pi over 12, I think that's in the first quadrant. Okay. And pi over 6, let's see, 6 will go in there, 30. Yeah, that's in the first quadrant. And I'm thinking 120, let's see. Yeah. I'm sure both of them in the first quadrant. So you would do sine of pi over 12 is equal to the positive square root of 1 minus cosine of pi over 6 all over 2. And that's what you would do with that pi over 12 question that was pulled up. And pi over 6, 180 over pi, that's 30, right? 30 degrees. The cosine of 30 degrees. Oh gosh, I can't even think. Let's see, what is that? Square root of 2, 1, square root of 3, 2. Be square root of 3 over 2. Somebody help me out. Sine of pi over 12 is equal to 1 minus the square root of 3 over 2, all over 2. Did somebody check me? Cosine of 30 should be the square root of 3 over 2. And nobody's going to say anything. I'm assuming I'm right.
Yeah, you're right.
2, 2. And that's going to give me the square root of 2 minus square root of 3 over 4, which is equal to the square root of 2 minus square root of 3 over 4, over 2. So you see, they're very similar, but you might have a different sign here or there, but the methodology is the same, the process is the same. Okay, next one. Looks like I got this one. This one is 10.337. Where's 37? I think that's this one. No. Wait a minute, that one just came in. Why you do that, Mr. Wexler?
I apologize.
That's all right. I'm just kidding.
I figured it out anyways. You don't have to.
Let me see what it looks like. I don't even know what it looks like. 10.337/9.
Yeah, it was just a straight up tangent.
Tangent of 5 pi over 12.
I needed to actually do the math there.
I'm sorry, what?
I said I had to finish like doing the math there. I figured.
Well, it looks like about the same problem.
Yeah.
5 pi over 12. I'll start you off. And I mean, hold on. I can't get my mouse to work. I'm about ready to throw my mouse in the trash can. So we know that 5 pi over 12, we're using a half number. So 5 pi over 12 multiplied by 2 is going to give you 10 pi over 12, which is equal to, we just did this one. Did we not just do this one?
We did the sine. Not the
Oh, I'm sorry. Okay. Well, you got to pull up the half angle for the tangent.
Yes, sir.
Okay, so that'd be 5 pi over 6. So, as we said before, 5 pi over 12 is half of 5 pi over 6. So 5 pi over 12 is half of 5 pi over 6. So I don't have my cheat sheet with me, so what I'll do is I'm going to go over here.
I can give you the.
That's all right, it's right here.
Okay.
Tangent of a over 2 is equal to 1 minus cosine of a over the sine of a. Now, in this case, a is 5 pi over 6. So tangent of a over 2 is equal to 1 minus cosine of 5 pi over 6, over sine of 5 pi over 6. I think that's what you had on your.
Yeah.
Okay, okay, let's see what you had. 1 minus and 1 plus.
Yeah, well, that was why I was getting kind of confused, because on the cheat sheet, the identity was plus or minus the square root of 1 minus cosine A over 1 plus cosine A. So that's
I'll
why.
have to check it out. I'll have to look at it. I don't have it. I think I've got it in the kitchen or the den. I must have laid it down somewhere. We'll look at it in just a second. But
Yes.
that's the one you're going to use.
Okay. Thank you.
All right, so let's do that. We know that the and I don't memorize things, so I'm going to go back and do this. We know this is 150. So 150 degrees, which would be 1 negative square root of 3 and 2. So the cosine, Oscar had a hunk, that would be negative. So that'd be 1 plus, y'all check me, 1 plus the square root of 3 over 2 over the sine. Okay, the sine Oscar had would be 1 over 2, correct?
It'd be minus root 3 over 2, because your root 3 is negative.
Yeah, but it's negative. Minus a negative would be positive.
Okay, yeah, I apologize. Yes, sir.
That's all right. But everybody else check me on the 1/2. And that's going to be positive. And looks like you're going to multiply that by 2. So that's going to be 2 times 1 plus square root of 3 over 2, which is equal to 2 plus square root of 3. That was the extra one. I don't mind that one. I kind of like that one because it's, well, these two that we just did. They're kind of, but you got to start off with this right here. Okay, I'm on. Why isn't it picking up everything? Is the resolution right on this thing? Hold on a second. No, somehow it messed up. There, that's a whole lot better. I was wondering why I couldn't get everything to show up. I must have turned it off and on. There you go. Let me highlight what you should. This right here is what you need to start the problem off with. Those three things right there, because this is A over 2. If that's A over 2, then this is A. And then once you do this sentence right here, you just plug in what?
Chug.
Plug and chug. Okay? Does that help you out?
Yes, sir.
Okay.
Thank you.
Well, let's see if that's the answer. Let's
It
plug
was-
and chug and see if that's the answer. 2 plus square root of 3. 2 plus the square root of 3.
So, when should we know when to use the different half angles for tangent? Because I was looking at another problem too, and it showed that as sine of
Hold on.
over 1.
Let me pull it up. Hold on. I got it in here. Just give me a second. I don't know what I did with the one I printed out.
That's the one I was using.
Oh. Well, hold on a second.
Did you post though? Didn't you post a half?
Yeah, I did. Let me see if I can find them. Remember, didn't I call them derived?
Yeah, yes, sir. I don't. So when it says half number, we should use these then.
That's it?
Yes, sir. Okay. Yeah.
Oh, okay. Remember I told you that you can actually derive these?
Yes, sir.
But I gave you the cheat sheet so you'd have them.
Yes.
If you did this right here, you would get the same answer.
Okay.
Because you'd have 1 minus the square root of 3 over 2, which would be 1 plus the square root of 3 over 2. Then you would have to use the conjugate.
Gotcha.
Because you would have.
That's how we get the same X.
That's how you get the same thing. You use the conjugate.
Yes, sir. Okay, that makes sense.
Do you understand?
Yes, sir, I do. Thank you.
Yes, sir. Let me pull it up. Now, where is it? I had it pulled up. Hold on. There it is. Right here. So if I have positive or negative, 1 minus cosine of x over 1 plus the cosine of x, then I could multiply by the conjugate 1 minus cosine of x over 1 minus cosine of x. And that's going to give me, down here, that's going to give me 1 minus cosine squared of x, which is what? The sine of x. So that's how you get that. And up here, you're going to get 1 minus cosine of x quantity squared. And if you did the derivation, you could either get the sine over 1 plus the cosine, or you can get 1 minus cosine over the sine. So I guess the best thing for you to do is just make sure you have this cheat sheet. So, and if you did the, and I'm gonna try to do this. If you did 1 minus negative square root of 3 over 2 over 1 plus a negative square root of 3 over 2, then let's see, that's going to be 1 plus square root of 3 over 2 over 1 minus square root of 3 over 2. And you also notice that here, and that's why I like to use these, what do you not have right here? You don't have the what? You don't have the square root. And if you don't have the square root, that's more work. That's why I use these. Okay? So it doesn't matter which one you use, you're going to get the same answer. Okay? And that's going to be the square root. And that's going to give you, and you can change this to 2 over 2 if you wanted to. You could change that to 2 over 2 plus the square root of 3 over 2 over 2 over 2 minus the square root of 3 over 2. And you could do it like that. And that'd give you 2 plus the square root of 3 over 2. 2 plus the square root of 3 over 2 over 2 minus the square root of 3 over 2, and then multiply by the fraction. The 2's will cancel, so you're going to get the square root of 2 plus the square root of 3 over 2 times 2 over 2 minus square root. You see what's happening? And you get the square root of 2 plus square root of 3 over 2 minus the square root of 3 right here. And then if you keep taking the square root and clearing, and if you do the conjugate here, you're going to get you're going to get one of them to cancel out, and you're going to get the same answer. Does that make sense?
Yes, sir.
Or did I just lose you? Try to use the one without the radical, and you won't have to work so hard. Does that make sense?
Yeah, yes, sir, it does.
Okay.
Thank you.
Now the next one, I'll just leave those two in here so I'll have them. The next one is, that's that one. Next one I got down here, 2.345. I don't remember that one. 2.340. There it is. And I think we did one like this one, but I'm not sure. We might not. I can't remember. I've done so many. We've done at least 15 or 20 of these problems in the last couple of weeks, and I'm starting to run together. Okay, this one, I have the tan. And I think this is the one I did last week. I'm not sure. The tan, let me. Tan beta over 2 given tan of beta is equal to negative square root of 11 over 5, and beta is between pi and pi over 2, which means that beta is in the second quadrant. Okay, now, did we do one like this, or do y'all remember?
I don't have one in my.
Okay, well, all right, and this is opposite over adjacent. Okay, there's 2 or 3 things you need to write down before you start this problem. First one is opposite over adjacent. Here, you need to make sure you understand that beta is in quadrant 2. Now, how do you find out where beta over 2 is? Well, you just divide all this by 2, and I'm going to do that now. So I'm going to take beta, and I'm going to divide everything by 2. And therefore, beta over 2, what we're looking for, that'll tell me what quadrant it's in. So beta sine over 2 multiplied by 2 over 1 multiplied by 1 over 2. So that's pi over 4. Beta over 2, pi over 2. So I believe that's in quadrant 1. And there's one more thing. You're going to be using tan of b over 2 is equal to, and you can use any one that you want to. Okay, I'm going to use the square root. You don't have to use it. Plus or minus. Well, we know that it's in quadrant 1, so I'm going to highlight the positive. And that's going to be 1 minus cosine of what? Beta over 1 plus the cosine of beta. Okay, so all of this, there's one more thing you can do, and that is the Pythagorean Theorem. Now, you know that beta is in quadrant 2. Okay, quadrant 2. So I'm going to put quadrant 2 right here. And that's going to be a -5 and a square root of 11. And of course, C is equal to, well, what's 11 plus 25? 36. And what's the square root of 36? 6.
6.
Now, all of that you need to have before you start this problem. Now, I didn't do a lot. Okay, what did I do? Well, this was all given. Okay, all I did, first of all, I added that opposite over adjacent. I made sure I recognized that this was quadrant 2, but that's beta. We need beta over 2. So I divided all that by 2, and beta over 2 is in quadrant 1. And then I wrote down the formula I was going to use and the Pythagorean theorem in quadrant 2 because that's where beta is. Now, when you're doing a problem like this, that's the first thing you should do is all of that. Now, what do you need? What do you need?
Your values for cosine B.
You need your value for cosine. Well, you got it right here. Oscar had a hunk, -5 over 6. Plug in what? Plug in chub. So this is, I don't even want to call this part 1 because this is really what you need to, I hate to use the word extract, but you should be able to extract all this info from what you're given. Now, this is what you need to do. Find cosine of beta. And then that's going to equal Oscar half hunk is equal to -5 over 6. And now plug and chug. So the square root, we know it's in the first quadrant. Going to worry about the positive or negative. We know it's in the first quadrant. So that's 1 minus parentheses -5 over 1 a -5 over. And I'm gonna pull a Dr. Hard. I'm gonna say, yeah. In other words, you know how to do this. And that means 3 dots. Yeah, square root of 11. And that's your answer. Okay. Next one I got. Let's see the square. Let's say that's a different. You have to redo that one. That's different. This one is 10.359/15. And this is a test question. I mean, all of them could be test question, but I like these because these are kind of short and sweet. Now, this one says, cosine of 2x over sine of x is equal to cosine of x, cotangent of x, minus sine of x. And they want you to verify. Well, that's when you pick the most complicated side, and I'm going to pick the right-hand side. And the first thing I'm going to pull up is my quotient identities. Right here. The cotangent is equal to what? Cosine over the sine. And what's the cosine equal to? Well, it's equal to 1 over the secant. But since we don't have, I think I'm just going to leave that cosine right now. You hardly ever want to change cosine into something else. Minus sine of x. So just using the quotient, I got something like that. And that gives me cosine squared x over sine minus sine of x over 1. Now what? What do we do now? That means I want y'all to talk. Well, we got 2 for, I'm sorry, what?
You have to multiply the right side by sine.
Well, you got to get a common what?
Denominator.
You got to get a common denominator because you got 2 fractions. So I'm going to put sine x right here. Sine x right here. And that's cosine squared. And this comes out 1. We'll go in there sine times. Sine times sine is sine squared. So now we have cosine squared x minus sine squared x over sine of x. Pull up your handy dandy identities. And where do you see cosine squared of x minus sine squared of x?
Could it be the Pythagorean identity?
Nope, that's what everybody goes to. That's plus.
Oh, the double angle identity?
Double angle. Cosine of 2 theta. So therefore, we got the cosine of 2 theta over the sine of x, and that verifies what we got right there. That's why I like these. I like these because they're very short, sweet, to the point. And we got another one just like it. Somebody sent another one, and I think I showed y'all this one last week. So I'm gonna let y'all do this one. And I don't even know. I'm gonna see if there's another one. Let me see. Let's see if this one is 59. There it is. Let's see if this one's it. Yep. Okay, I'm gonna let y'all do that one. Give y'all a couple of minutes. I'm gonna put the clock on you. My headache's about to kill me. I'm gonna have to take some. I can't even get the daggum thing started. There we go. Give you a couple of minutes.
Priority 1 message coming in on secured channel. You have a work email.
All right, that's close to 2 minutes. And I think I gave y'all this one the other day on the Word document and told you to copy it down, but I don't know if you had enough time. 2 cosine of 2x over sine of 2x is equal to cotangent of x minus tangent of x. And of course, the first thing you're going to do is notice this cotangent and tangent. I mean, that's a given. This is cosine over sine, and this is sine over cosine. You got 2 fractions, you get a common denominator. You get a common denominator. The common denominator of sine and cosine is sine cosine. How many times will sine go in here? Cosine times cosine is cosine squared. How many times will cosine go in here? Sine times sine is sine squared, and we've got I believe that might be a misprint. It's supposed to be sine cosine of 2x. Sorry. That's wrong. Okay. And we should have cosine squared minus sine squared is cosine of 2 theta or 2x or whatever. And then sine cosine is the sine of 2x. And that's verified right there. I don't know how they get the 2 there though. I must have done something wrong because hold on a second. Let me pull up. That's not what I want to pull up. Oh, there it is. 2 sine. There it is. Well, it should be sine of 2 theta equal to 2 sine cosine. Well, that should be up top. I've got something backwards. That's equal to 2 sine of 2 theta. And I'm supposed to have 2 cosine of 2 theta. So I've got the 2. Somehow I've got the 2 backwards. Sine, cosine. Sine will go into sine, cosine squared, sine squared. Cosine squared minus sine squared should be 2 theta. Cosine of 2 theta. And then I've got sine of 2 theta equals sine. Wait a minute. No, I've got something messed up somewhere. Two sine cosine equals sine of 2 theta. I'll have to come back on that one because I don't know what I've done wrong. I've done something wrong. Let me get on to the next one. I got 2 more. I got to get finished. 10.3. I got one more. And this one is not, this one's got like 618 parts. I got to find it. It's 10.387. 10.387. Okay, let me see which one. I think I got 2 or 3. Let's see, I got 172. Let me see if that's the first one. Nope, I must have had a third one. So I'll just do this one. Okay, amperage, blah, 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 blah. And I've got voltage is equal to 172 sine of 140 pi times T. And that's for voltage. And then the other is the amperage. And amperage is equal to 1.14 sine of 140 pi times time. Now, they tell you to graph, I think they tell you in A to graph, blah, 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 blah. Graph W is equal to the voltage times the amperage. So, what, I'm sorry. The total wattage is equal to the voltage times the amperage. Wattage is equal to the voltage times the amperage, which is 172 sine of 140 pi t times 1.14 sine of 140 pi t. Well, when you multiply those two things together, you basically just get a square on the sine and whatever this comes out to be. I got 196.08, but let's check it. So 172 times 1.14. 196.08 sine squared of 140 pi t. And that is what the wattage is equal to, and that's what they want you to graph. Now, I really don't care about graphing it, but when you graph it, it's going to look pretty much like that right there. I'm sorry, hold on. It's going to look like this right here, pretty much. And you can find your max and your min. The max is the amplitude, which is how high it goes. And the min is going to be 0. And they also tell you they want you to graph it at these windows. And I'm not going to go through all that. Y'all can do that. Okay. The maximum. Well, the maximum is going to be at 161. And you can do that when you trace it. The minimum light bulb is going to be 0 watts. So you just have to go to the max, find the max, and of course the min is 0. And I guess okay, and now they're saying use identities to find the values. This is C. To find the values for alpha, and that's, I think that's sigma. I can't remember if that's sigma or, and C, so that W is equal to A cosine of sigma T plus C. Do not include the unit in your answer. Okay. So we know that the sine, so this is C, we know that the sine, I'm going to just make this big. We know that the sine squared of 140 pi t kind of resembles, or we want it to look like the cosine of WT. And we also know that this looks like sine squared theta. So what I'm thinking of is the cosine of 2 theta, which kind of looks like this, is equal to 1 minus 2 sine squared theta. Now, how did I come up with that? Well, I know that my answer needs to look like this because of what the question tells me. And I know that I've got something like this, which looks like sine squared theta. Sine squared theta. So then I say, well, do I have something? Do I have an identity that's got cosine of something equals sine squared? And you go to your handy dandy, and I can't find it right now. There we go. So I want to find something cosine of 2 theta or cosine of something is equal to sine squared. Cosine of 2 theta, 1 minus sine squared. So that's what I'm going to use. Now, if I take, I'm going to take this on the next page, and if I do cosine of 2 theta is equal to 1 minus 2 sine squared theta, and I solve for the sine squared. Well, that's going to give me, well, I got a minus 1, minus 1. So cosine of 2 theta minus 1 is equal to negative 2 sine squared of theta. Divide by negative 2. What in the world is that? And that's going to take that off. So sine squared of theta is equal to cosine or negative cosine 2 theta minus 1 over 2. And you could make that 1 minus cosine 2 theta over 2 is equal to sine squared theta. Well, sine squared theta, that looks like the sine of 140 pi t. So I could take that original equation, which is W is equal to 196.08 sine squared of 140 pi t, and I can substitute this in for that. Now, when you substitute that in, let's see, that's going to be cosine of 2 times 140. That's going to be 180 pi t over 2. So I'm going to go to the next page. I'm going to rewrite that. Except this time, I'm going to put 1 minus cosine of 2 theta over 2 is equal to sine squared theta. And W is equal to 196.08 times sine squared, which is this. So that's going to be 1 minus cosine. Well, 2 times 140 pi t is 280 pi t over 2. Now I'm going to distribute this, and that's going to give me W is equal to 196.08 minus 196.08 280, I'm sorry, cosine 280 pi t, all divided by 2, and that's going to take these 2 down. So W is equal to 98.04 minus 98.04 cosine of 280 pi t. And now I have, this is W, or little w. I'm sorry, no, that's not right. This is A, this is W, and this is C. So those are your answers. Is this a good question for a test? Hell to the no. I would not put this on a test. This is a good homework problem, but it's not a good test problem. And really, it's kind of outlandish for a homework problem if you want to know the truth about it. Okay? Now, that's it. I've covered just about all the dadgum questions I can cover. My brain is about shot when I'm getting through with these identities. I know how you feel with identities because they can be frustrating. So go ahead and send questions. I'll give y'all one last day for homework, which will be Tuesday. But we're going to get started on cosine, law of cosines and sines Tuesday also, because I got to get that under your belt before you get into calculus. So I'm going to go ahead and check the roll, and I'm going to shut her down. And I know that y'all's brain is about fried.